This video is a demonstration of the software prototype for the SOIS device discovery mechanism implemented on the MIL-BUS 1553. The software, as you can see, is composed of three main tabs. The first tab being the plug-and-play discovery, which allows a user to start and stop the plug-and-play simulation and issue device discovery requests on the underlying device discovery service. The request can be either asynchronous or periodic, and from this tab the user can also have a graphical view of the retrieved plug-and-play network status and layout with detailed information on each plug-and-play device. From the MIL-BUS 1553 tab, the user can set all the parameters related to the subnetwork underlying the device discovery service. These parameters are for the bus controller and the remote terminal. For the bus controller, the user can set the minor frame time and the number of major frame executions. I want to remind that the plug-and-play service is implemented in a single minor frame, executing the polling of all the available the possible RT addresses, asking for the RT to transmit all the content of subaddress 1 to the BC, and there is a single plug-and-play minor frame defined for each major frame. In this case, the time allowed for each minor frame is 1 second, with the major frame executing cyclically, because zero value is a cyclic execution of the major frame. For the RT, we can enable a number of attached devices, and for each device we can specify the specific class and type of the device enabled. As you can see, the device discovery service now is not operational and will be enabled later on during the demonstration. And finally, from the log tab, the user can see all the messages related to the software execution. As you can see now, the messages show that the DLL file has been loaded, and the addresses of all the DLL exported procedures have been acquired to be used in the software, and the execution of the initialization of the API software library application interface has been successful. Now, before starting the device discovery service, I will define all the plug-and-play information to be stored within the RT memory at subaddress 1, the subaddress dedicated to plug-and-play, and I will say that the simulated RT address is number 5, and I will enable 3 devices attached to this particular remote terminal, and for each device I will define a class and a type. The actual value doesn't matter at this stage. Okay, now I'm ready to start the device discovery service on the MIL-BUS 1553. Before starting, I will put the minor frame time to 1 second, so we are able to better the polling process from the log, and I start now the device discovery service, and we can see from the log that the bus controller is polling all the possible RTs for transmitting the content of subaddress 1, which contains the plug-and-play information, and we don't see yet any network status appearing in the main plug-and-play discovery tab, simply because the user is not requesting the device discovery to send this information. The request can be done asynchronously or periodically. If I ask the Device Discovery Service to retrieve the plug-and-play network layout, you can see that the devices that we previously set from the Milbus tab are being discovered, subaddress 5, 11 and 19. As you can see, 5, 11 and 19, they have respectively these devices attached, and for each device I can select the description and retrieve the specific information like communication subaddress, to which RT the device is attached, and the device class and type. If I now set the device discovery request to be invoked periodically, let's say every 1 second, we will see how changing the RT plug-and-play information at runtime will still allow the Device Discovery Service to retrieve the right information. Let's say now we disable subaddress 19 and we change type of the device attached as subaddress 11 to be 5. We didn't set the RT memory yet, we do it now, and you can see that the new plug-and-play information are retrieved correctly. If I now stop the Device Discovery Service from working, we can see from the log how the RT addresses are polled each time sequentially, and how the RT address 5 sent its plug-and-play information, and how this information, which is basically the content of subaddress 1, is being retrieved by the bus controller side with specific definition of each device attached to the RT being simulated. And this concludes the demonstration. Thank you for attention. Bye.